Hello and welcome back to the development of the Feersum schema compiler. So in the last stream I was looking at adding position information to the syntax tree that we get after we pass the source code. So this is kind of part of an ongoing move to try and improve the diagnostics that we give if the program isn't well formed. So the parser produces diagnostics for syntax errors now, which contain location information, and if the parser fails in certain ways, it will actually continue on stubbing out parts of the tree, so we can actually get more than one syntax error. The syntax tree that we get at the end of that now has position information on it, so that's passed into the next stage of our compiler, which is the binder, and the binder's job is to take that syntax tree and turn it into some kind of semantic understanding of the program. At the moment, if there's anything wrong with your program, like you reference a variable that you haven't defined or something like that, then the compiler just throws its hands in the air, uses fail with, so it just throws an exception. So the job of today's stream is going to be going over the binder and replacing all of those throw exceptions with actually returning a diagnostic instead. But let's start by going over what happened in the last stream, just so that I can get back into the groove. So we had this text location, which is used to store the location of our diagnostics. Previously we were just using a position type from fparsec, but now we've got a location which can either be a single point or a span starting and ending at 2 points. Diagnostics now have toString, which uses the start position of the location. We did some work to the AST node. So previously this was all one type, but now we've got an AST node kind, which takes a node type, and then we have an AST node which has a kind and a location. So the reason why this is done like this is that we can have the same AST node kind but with different node types as we map it from one place to another later on in the compiler if we want to. So we could make transforms over this syntax tree that collected more stuff into the node. So the AST node might have like a kind and a location and other things if you wanted to. So that kind of thing might be useful if you're writing a code formatter or something, or if we need to hold on to all of the underlying tokens for a given node. I don't know. Then the rest of the work was mainly the new parser combinator for spanned node and span node of kind, which takes a parser to parse the node and a constructor, and it basically stubs out, it retrieves the position from the parser, runs the inner parser, then gets the position again, and then uses the constructor function you've given it and creates a span. So this is how we end up with syntax nodes with a given kind and the location annotated onto them. So the job today is to have a look at the binder and support emitting diagnostics. So the main entry point for the binder is this bind, which takes an AST node and returns a bound expression. So this should probably, binding context should probably return a bound expression and a diagnostics list. I think what we'll do here is the same thing the same thing that happened in the parser, where effectively we use the context to buffer up the diagnostics. And so we'll have a mutable diagnostics, which is of type diagnostic list. And then when we create a new binder context, we'll start out with no diagnostics, and we'll add on to this diagnostic list if we see anything that we need to return an error for. And then at the end down here, binding context should actually call binding context and then return context.diagnostics2. So we end up with a tuple of bound expression and diagnostic list. That's probably broken something. It seems to have broken the interpreter, because the interpreter is expecting execute bound. This should probably be so yeah, we can't really do that. We could, because this execute bound gets called recursively. It's not really very easy to just change the signature of the function like that. But what we can do is bound equals binder, and then if we have any diagnostics, if there are no diagnostics, we will execute I'm not very good at typing. Not just today, I'm not very good at typing, full stop. So that and bound. Otherwise, we will return some kind of error. This is the interpreter, so I don't really care that much. Undefined, sure. In the compiler, we also call the binder, and then we pass the output to emit. So compile is called from a few places. It's called from the evaluator when we make a memory stream, and it's also called in compile file. So what does the evaluator do? Evaluator will return see, this could be a result, couldn't it? That's probably what execute should do as well. This should probably be something like okay, and the failure should be an error of the diagnostics. And could make the binder return a result as well, but you might want to get access, you might want the binder to always return some kind of tree, even if there were errors in the bind, and just have certain parts of the semantic tree just broken. What's going wrong here? If expression needs to have type scheme value to satisfy context type requirements. Where are you called from? Execute. Oh. I guess we want to say scheme value or diagnostic list. It's the wrong error. That looks a little bit nicer. I don't know where execute gets called from, but we're going to end up doing the same thing to eval, I think, where eval will return a diagnostics list or return the object. So I'm going to wait to fix that until we've fixed the evaluator as well. So I think this can be something like we do the bind and then pipe it to results.map. What does emit do? And the result of the binder isn't a... So really we just want the compiler to return a list of diagnostics. So if we've got any diagnostics after binding it, then we'll return whatever emit returns. Otherwise, we'll return the diags. I guess emit can't fail at the moment. Yeah. So now compile returns a diagnostics list. We're doing this compile file already returns a diagnostics list. So we'll do this and fix that to do. And we only want to emit this metadata when the diagnostics list is empty. Things are looking better. In the evaluator, we compile, and if there are any diagnostics, what do we want to do? I think we want to say if there were any diagnostics, we can return an error if there weren't any diagnostics. We load the assembly, invoke the main method. I guess this just wants to be just going to rethrow that. So this, I believe, is not actually ever going to get hit, but we just need it there. Ah, yeah, that must be if not. And then in program, we've got both eval returning a result, obj, execute returning a result. So we can I guess this wants to be composed with result.map again. And then we'll end up with a result of unit or which the REPL takes is an evaluator, which is supposed to be AST node to unit. But the evaluator, this is giving, here is going to be AST node to result. Where's REPL called from? I'm trying to work out why the type is inferred to be unit. It's called from REPL and run REPL and run REPL. So if we call our evaluator and then we match on it, and it'll return a result we don't care about. Should map through to unit, or we get some diagnostics which we want to dump out. Do we have a way of, we already print the diagnostics when the parser fails, so what do we do there? Compile single, compile file, no, that's for when we're running this, not interactively. So we do read expression. If we got some diagnostics, call read again. So read's just going to continue to retry until we get something. But I guess this wants to be something like dump diagnostics. And dump diagnostics is going to do this. It's going to take the diagnostics, reverse them, and then write them to the standard output. Oh no, standard error. Write the diagnostics. And that returns unit, so we can use that in the place of when we got our error here, we can just do dump diagnostics. That's the program working. Let's fix up the test so at least they compile. Up here we are doing execute, which are AST node to string, AST node to string. Yeah, I just need to result that map there, I think. And then these evaluators, this is going to have to be okay of that string. Oh, that's not going very well at all. I love a good multi-cursor edit. I suppose we can try some evaluators in a bit that don't work. Is there a result.unwrap? What I kind of want is a way to do r.ok. But let's just write a little helper function to do that. I'm just going to go and undo the tests I've made to those test cases, changes I've made to those test cases so far. So in the evaluation tests, is there anything of any use in here? Change-wise, nope. Let's just revert the whole file. Remove all evidence and try again. Or expect okay, I guess. So function that if it is an okay, it returns that. Otherwise, it does fail with expected. Okay. And then we can use that here, expect, okay. Let's run the tests, they might even work. It's going to be in the terminal, maybe? Yeah. Oh, we're still going. Nice. So let's have a review of what we've done so far. So in the binder, we've now got a list of diagnostics, which we don't do anything interesting with, and return when we call bind. Good. In the compiler, we handle the case where the binder has returned diagnostics. In the evaluator, we handle the case where the compiler, where the binder has returned diagnostics, or the compiler. In the interpreter, we handle that same case in the same way we do in the evaluator. In program, we now dump the diagnostics if we got one from the parser in read or in the REPL. And in the eval tests, we handle the case where we got diagnostics. I'm going to commit that as API changes for binder diagnostics. Introduces diagnostics list to the binder return type, but doesn't produce any So let's go to the binder and add a diagnostic. So I'm going to run the program and we'll see what we currently get error-wise if you try and do something like reference a symbol that's not defined. I'm going to go over why and how that's different to what happens when we have a syntax error. So if I have a syntax error, like try and do foo and then like try and add one, and I forgot the closing one, we get missing closing. In fact, if I got two missing closings, I get two errors. In fact, these are both actually at the same point. Yeah, and this is the reference to undefined symbol foo. So in this program, we've got a sequence of two things. The first one's the call to foo, and the second was a nil, or null literal. We just get this system exception. So it'd be nicer if we got these errors that were in the same place and told us where we'd actually made a mistake. And the reason why that's important is, say I do foo bar baz, and it says, reference to undefined symbol foo. It'd be nice if we knew about all of the undefined symbols. And also if I do foo, 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 it just says, reference to undefined. it doesn't tell you which one of those is actually broken. So in the binder, let's go through everywhere where we throw an exception. So reference to undefined symbol is in bind ident. So what we're going to do here is we're expecting the bind ident is supposed to where's this called from? Trying to work out whether or not this is actually a useful function to still have. So we have, if it's AST node ident, we bind it and convert it to a load. And if it is a set bang, if it's a set expression, we use it to look up the storage for a store expression. Okay, so what we're going to need to do in this case is emit a diagnostic and then fabricate some kind of load or fabricate some kind of storage ref. So what we will do is we'll start with our existing error message, but we'll omit that as So the trouble with this bind ident is you don't actually really have enough information to properly emit the diagnostic here. So what I might do is, it was only called in 2 places, and it itself was pretty simple. Because all this is doing is binder context try find binding. And if we get rid of this and fix up the 2 places where it's broken, we can have a better error message in each case. So let's match binder context try find binding in this current context with the ID we've been given, and we either get some storage and then we emit a load from that, and we get no storage, and so we do context.emit. We need to get a position, so we're going to do node.start node.span or node.location. I can't remember what I called it. Node just gonna go to span and to undefined symbol. So much blue squigglies. I'll get to it. Chillax. We don't have an emit yet. Fair enough. So let's go add one to the context. Well, there's a load of these functions here which are actually yeah, these are all like module level associated functions, so we'll carry on doing that. Emit diagnostic. So position error or message, and this is going to do, it's going to create a new diagnostic. With the position and the message, and then it's going to do context dot diagnostics is diagnostic So here we can do it's going to complain because we need a bound expression dot something here. So we're going to have an error expression type in the bound tree as well, to handle the case where there's a problem in the program. It's called location, not span. And down here, bind ident, we're going to do same thing. Bind a context, try find binding for that ID, match it. But the thing is, here we can say if we got some storage, we can return our expression as before. If we didn't, then we do binder context dot emit, and we are going to say set, or attempt to set something that not yet define ID. Then we're going to emit that at, what are we matching over here? Can I just do node.form with, I think I need to capture the location. So that wants to be a semicolon. That needs the binder context. And we need to return an error. Would it be useful for binder context emit to return an error? I don't know yet. But early indications are that we don't have, we do have errors. Why do we have errors? The problem is if we've got an error. That should work. And then here in the evaluator, I think the interpreter already has a catch-all where it says, yeah, bound expression is not supported. Not bad. So if I do foo baz now, what do we see? Reference to undefined symbol foo bar baz, which is what we wanted. So I guess what's changed in the compiler? Yes, handling the error. And in the binder, we've got the new error expression. We just want to delete this, I think. For the bind ident, we try and look it up, and for the set, we try and look it up. Okay. For references to undefined symbols no longer row. Instead, return. So let's have a look. What's the next throw? So if we've got a formals list, what is bind formals list returning? We need to go to the proper editor to do that. Right at the top, please. Tube 1. So our formals list only expected a single ID after dot. This is returning a bound formals. So I think bind formals list needs to take a context where we call it from. Needs to take a context so that we can raise those diagnostics. And then when we bind the lambda body, we need to pass the context in. And when we call bind formals, we need to pass the context in. Value is not a function. Bound formals. Oh yes, okay. Which is bind context formals. Good. And then up here in bind formals, we'll need to stub out whatever formals stuff. So I think if we've seen, in this case, this is the case where we're getting more than one dot, or more than one identifier after the dot. So it's supposed to be like ID, some list of IDs, and then a dot, and then an ID. And we've had more than one. So in this case, we can just do bind a context dot emit 4. We just need to omit the diagnostics there. And then if we don't get if we get anything else, we can just return the accumulator we've currently got, and we can do if I could spell location. So yeah, in these cases we just need to find something to return. And then in this case we're looping through the list, but we haven't seen a dot. We'd expect to either transition to the I have seen a dot state, or we'd see an ident and we add it to our list. For anything else, I guess again we can just emit the diagnostic and move on. And we're just going to return the existing accumulator. That surprisingly still type checks. So in this case, it's a little bit more complex because we need to we saw a dot but no ID in the formals. So in this case, we can say we can omit a diagnostic for the fact that we haven't seen an identifier. Where are we going to attach that though? We need a location to attach that. So what you could do is take it over the whole list of nodes, or we could just say that we know that the last one in there must have been a dot. So we can do list dot last, on the formals dot location. And then we can return bound formals dot list with at least the formals that we did see. What's going on here? Expected, but here it has string list bool option. Ah, yes, because I really wanted formals there. Right, so let's try some of those out by writing some lambdas and things with malformed formals lists. Gonna check that off. We're using syntax position for some errors at least. So if I do define foo with nothing, that just returns 1. Reference to undefined symbol define, because that's not how you spell define, and that is still not how you spell define. So we get a procedure. But if I say foo dot and then nothing, it's at so dot but no ID in the formals list, and it's saying from line, it's at line 1 column 14, which is probably going to be where that dot is. Let's try. 1, 2, 3, 4, 5. Is that right? I don't know. 2. Yeah, that's position 14, so it's pointing at the dot. So other ones would be define foo where we expected an ID, saw a dot but no ID in the formals. Yep, that seems acceptable. You'd get 2 errors for that. In this one, how about we say foo fg expected an ID or a dot in the formals. So how about bind formals itself? We've got the case where the formals list is a single ID or it is a list. So what we could do here is we could say we can emit a diagnostic in this context with the formals. What is the formals here? It's a node, so it'll have a location. So we can just give it any. We'll give it the same message as before, and I'm gonna do the old pipe it to it trick because I failed miserably that. It makes it a little bit easier to read. So we emit the diagnostic there, and then I guess what we could say is we'll just return a bound formals of a list with nothing in it. So this is not the only case where we've got an internal compiler error and we're returning a different message in each case. I'm just going to make this the shorter message. So it's perfectly fine to throw here because this is something that should not happen if there isn't a bug in the compiler. It's not to do with there being a problem in the user's code. To attempt to bind an error expression node. So here we've got another expression. We can say again we'll return a bound expression error and we will omit a diagnostic. The location is just going to be node.location. So this will cover cases where you use a dot outside of a pair. We don't actually support any syntax yet for making like a dotted pair or anything like that. So it's basically any time you try and use a dot other than in a formal parameters list for a lambda definition or in a defined form. Lambda defined form. So if I just do dot, oh yes, it needs to be syntactically valid to be syntactically wrong, semantically wrong, right? Or if I just do dot on its own. And let's also try the case where we do a lambda. So it needs to either be an ID or a list. But if I do like that, unrecognized formal parameter list, it must be an ID or list pattern. And that's on line 9. Line 1, column 9. We do actually have spans. I'm just wondering about getting the original source text, finding the line in the source text, and then doing the thing which Clang does where you put a little squiggly underneath just the bit that's wrong. At the moment we're getting the column information though, that's enough to at least know roughly where the problem is. Onwards to the next one, we've already done the ident binding. Let's get back to the find or fail. Ill-formed if special form. So I guess for these ill-formed special forms, we've got quite a lot of them, and all of the they're basically the same, but they just say, oh, it's an ill-formed set expression or it's an ill-formed if. So what I'm going to do is introduce ill-formed, which is going to take a form name and this is going to do something like say ill-formed or whatever it was. So we're going to take the form name make a diagnostics out of it, emit that diagnostic for the form.location and then we'll return bound expression.error. Y is where does bound form get called from? I'm wondering whether or not we could do the same trick with taking the first and the last one. Like here we would know the span of the node. Yeah, I'm just going to pass the span in here. The difference being that we could, if we calculate the location from the form itself inside, we will miss out the opening and closing brackets. But if we do, if we take the location as another parameter, then we can include those brackets in the error message. What went wrong there? Debugger's out of sync with the terminal. Right, let's see. So if we try and write an ill-formed if, so if we just do like if and then don't do anything else, yeah. So it says line 1, column 2. Why? I was expecting that to be line 1, column 1 because I was expecting it to start pointing at the opening brace. So 1, 2. It's pointing at the start of the if. I'm just going to go and put a breakpoint in the main program where it's printing out these diagnostics. And we'll have a look at what the diagnostics are for that and see where the end of the span is as well. So it says line 1, 6 to line 1, 11. Maybe it would have been smarter if I did it when it wasn't indented. So that's going to be 7, 8, 9, 10, and then 11. So it is pointing just after the F rather than just after the... So the span is going over those things. And ideally, have it go over those. So the question is, if we're taking the location from the form, why does the form not include the brackets? That's going to be a parser problem. Parse form. Because we skip it and then we do spanned node. So if I get rid of that, we get a parser of AST node list. But then how about if I then take that whole parser and do a span node form for that? Hopefully that should be the fix that we're looking for. Because each one of these individual nodes in the inner list, in the many, will have their own spans that cover them. We want the span for a form like the if expression to cover the whole if. And we probably don't need that breakpoint anymore. Yep, ill-formed. This could be line 1, column 1. Nice. Found a bug in the parser as well at the same time. Onwards. So where's the next time we reference fail in the... Yeah, we can just use ill-formed again here. So that's going to be ill-formed. Ill-formed define. And this is an ill-formed lambda. Let bindings not yet implemented. I think it's probably okay for us to just throw on that ill-formed set. A bunch of other not implemented. So I think that's it. I think that is all of the semantic errors that we currently detect in the binder turned into diagnostics. We should go through and spend some time in future episodes to try and get rid of some of these not implemented. A lot of them are things like let stars and let rect we can probably tackle. Have a stream on let bindings and things. Quoting, not sure yet. And we can transform an and into an and an or and a cond and things into just a whole bunch of different ifs and stuff. But I don't know if we want to do that with macros or do it in the compiler, in the binder itself. I feel like doing it with macros might be more schemey. Which would mean work on the macro system as well. So one form that also not handled here is the syntax, define syntax, I think it's called. There's a macro for defining macros. So we'd need to have like a way of having built-in macros, and then we could have like and, or, and cond and stuff as built-in macros. There's also work to be done on having some kind of standard library available to the programs, because at the moment you only have what you write, and I think the built-ins, which is basically just this bunch down here, so nothing super interesting. But being able to search for those built-ins in .NET Assembly, so we can have a .NET Assembly that contains all of our like built-in scheme built-ins, and then also have the ability to define libraries that are written in Scheme, so we can start defining macros and things for parts of the standard library that we don't yet support. But in terms of position information in the binder, I think we're done here. So we can try producing some of those errors again. So we've got things like lambdas. So a lambda that's not got two things in it, I guess, would be. Or yeah, a lambda that's completely empty would be the only way I could think of to do that. Because if you've got this body, could still be just an empty list. I think if you did like lambda foo, that still compiles to basically if you called it would return nil. Yeah, I don't know if that's actually exactly how Schemes says it should work, but this is our compiler, we get to make those decisions. But I've had a lambda which didn't have anything. We get a form of special form. What else we got? We got ifs. We've already done. We've also got define. So if you do a define where you don't give it an ID, or you give it an ID in more than one value, or just anything, like if you try and define, that's not going to work. Yeah. But that would. Good. Well, I'm just going to review what I've written here, commit it, and then call it a day. Relatively quick stream in the end. So we added the diagnostics to the formals, and we added diagnostics for the dot. We pass in the span that covers the whole form to bind form so that we can do this ill form special form thing. We converted all of our ill forms special forms. We've done bind formals list with the context. Relatively simple in the end. For remaining panics. Stub out state as well. Thanks for watching. I hope you've enjoyed this relatively simple stream in the end. So we went through, and for all the places where the binder was throwing an exception when it found a semantic error, we instead buffered up a diagnostic into our binder context, and then at the end the binder returns all of the diagnostics it encountered. And this allows us to bind trees that have got semantic errors in them, and we always end up with some form of bound tree which may or may not contain an error expression. And that's it for today. So I will see you sometime in the future.